United Kingdom started their own version of IDD and they call it Digitally Built Britain, or in short UKDBB. During the design stage, they envisaged that the industry will deploy digital techniques to design better performing buildings, homes and infrastructure, use good practice, secure by default, information management to get the data right from the start. During the building stage, the system will encourage or get the industry to exploit new and emerging digital construction and manufacturing technologies and techniques to secure, share information, enabling clients, design team, construction teams, and the supply chain to work more closely together to improve safety, quality, and production during the construction stage. During the operation stage, to use real-time information to transform the performance of the as-built environment and its social and economic infrastructure. To have smart asset management to predict and avoid disruption of services. And to digitize existing assets. And also to understand how spaces and services can improve citizen quality of life and feed that information to the design and build of our economic and social infrastructure and the operation and integration of services that they deliver. In Singapore, we hope to achieve a similar set of outcomes, but we are using what we call the IDD plan. Our IDD plan, in essence, is to get the various stakeholders in a project to use BIM as a backbone for their design, for their construction, for their fabrication, and during the facilities maintenance and operations period. And then also to make use of the virtual design and construction methodology and the tools and technology to first build virtually so that the problems that have been encountered because of the design is solved in the virtual environment, and then go on to build it in the physical real life, the world. And at the same time, then try to harness the ICT tools to then have a integrated digital deliveries. So resolving the construction issues virtually through collaboration, and then after that, delivering the virtual design and construction resolutions, with digital solutions for fabrication, construction site, and logistics. The idea is to have digital solutions to convey relevant, accurate, and timely information so that we can have collaborative working approaches and integrated platforms to achieve timely, cost-efficient, productive, and high-quality project delivery, all through IDD, throughout the different stages, right from the design to the manufacturing, to the assembly, to the facility operations and the maintenance stage. It is envisaged that through IDD approach, in the design phase, there could be collaborative and coordinated design and usage of the computational tools. During the construction or the manufacturing phase, there could be IDD tools to enhance automation and to use robotics for optimization. And in the construction site, where you are doing the construction or the assembly, you can have real-time ITC solutions and to have lean construction. And finally, when the project is handed over to the end user, there could be digital tools to enhance the operation and the maintenance, for smart and sustainable assets. So through the IDD approach, a firm can benefit in the following way. There can be improved productivity and better performance because you can have an informed decision making from a single source of truth which comes from the BIM model. So that can lead to an improved workflow, better resource management, and faster turnaround time. There will be more connected project chain value, where digital platform can ease collaboration among all different stakeholders, from the design to fabrication to construction, for better documentation, better audit trails of records, and improved quality assurance. And there could be better safety and risk management, because digital tools can be utilized for proactive on-site safety and risk management. The benefits to the project can be in terms of time, cost, profit, safety, and quality. In terms of time, through proper usage of IDD, we can meet or shorten the target construction period. We may be able to reduce the floor cycle time or reduce the extension of time claims. In terms of cost, we will be able to reduce the waste and the amount of rework. We can maximize our target cost. We can reduce the construction cost and reduce the contingency amount. The profits will actually increase because we will be able to maximize the sellable area or floor efficiency. At the same time, we get a safer environment because we are able to improve site safety. We will be able to reduce the number of incidents and accidents, and hopefully go and have a project where we have zero fatal accidents. And the quality will also be better, due to the IDD approach. The IDD approach can also offer value to the different stakeholders. For the owner and the developer, the value comes in the form of having the best design outcome for the project. There will be an improved cost, time, and quality project goals. There will be more accurate and reliable digital asset information, and as a result, the owners get an enhanced value for their asset. For the designers, they will be able to have a faster and better design options. They are able to better design, coordinate, and have a reduced amount of requests for information, and they can improve their competitiveness. For the contractors, there will be a reduction in the risk that they need to take. There will be a reduction in the amount of rework that they will need to do. There will be a higher accuracy in their bidding, and there will be more time for value engineering and to improve the safety on site. For the fabricator, they will be able to produce the shop drawing faster and get approval faster. There will be automated translation of design to the production or fabrication, and they are able to improve the production management. And finally, for the facility management team, they will have a more cost-effective operation. They can enhance the life cycle management, and they will have real-time access to operation and maintenance manual, and they can streamline the maintenance regime. Using of IDD by the various stakeholders in a project will be able to obtain value-driven outcomes and allow the streamlining and transformation or transforming of the various processes so that there can be better integration for the different stakeholders or for the benefit of the project. At the same time, all the stakeholders will be able to make use of the digital data that is available to be collected on a common platform to find solutions through data analytics or intelligence. There are 4 stages to the IDD approach. In the first stage, which is the digital design, we are engaging the stakeholders to achieve optimized and coordinated design that can meet the clients and the regulatory and downstream requirements. When we are sufficiently advanced in the digital design for our project, we can go on to the next stage, which is the digital fabrication, where we are translating the design to standardized components for automation off-site production. When the production has already started and we are getting units churned out in the factories, these units can be delivered to the construction site And that is where we go into the next stage, which is digital construction, where we can have just-in-time delivery, installation, and monitoring of on-site activities to maximize productivity and minimize rework. Finally, when the project is completed and handed over to the client, it then goes on to the fourth and the final stage, which is the digital asset delivery and management stage, where we can have real-time monitoring for operations and maintenance to enhance the asset values of the buildings or the projects that have been completed. So during the digital design phase, the architect can use computational BIM to generate different design options for the client to select. And the engineers can perform sustainability analysis on the design, and contractors and fabricators can give early input on the constructability of the particular project. The developers can also use VR collaboration tools to visualize the building that finally they will be getting. So all this can be on IDD platform, where we are talking about a common data storage, data exchange, data processing, data mining, data analytics engine, and machine learning platform. And you can have common standards for regulatory monitoring and approval. The model then goes on to the next stage, where we call it the digital fabrication. The fabrication can use the digital DFMA model for production of the various units. The supervisor can monitor all the activities in a centralized control room. Digital data and robotics are used to drive the machineries and installation sequence. Digital IDs are embedded into the DFMA modules. The DFMA modules are then delivered just on time to the site for the next phase. In the next phase, the digital construction, the contractor uses BIM to plan the construction activities and scheduling. The contractors uses BIM to field technology for setting up. The project manager can monitor the site activities and track progress, for example, using drone or other technologies. The crane operator, for example, can operate a smart crane. Finally, the building or the project is handed over to the client. The contractor can use tablet to check construction versus digital model and record down all the defects. The digital assets are handed over to the client or the building owner. The building owner and the facility management or maintenance operator can monitor the building performance using real-time live data.